Welcome back, students. We're going to continue with the second part of our 8.2 ellipses unit. We're going to go fairly quickly through this formula part because I really do just have this here for reference. It's not a list of things that I expect you to memorize. In fact, trying to memorize this would be just an exercise in frustration. The A's and the B's switch places, the plus or minus C and plus or minus A switch locations. It just makes it really, really hard to try to memorize, which luckily we don't have to. It's much easier to focus on what is reliable, what always stays the same. And everything that's part of the X block, the block involving X, everything in that block is a horizontal measurement. Everything in the Y term is a vertical measurement. So the H in the numerator part, the H is the X value of the center point, and the K is the Y value of the center point. And it's the same no matter which way the orientation goes. The denominator of the X term is the square of half the horizontal axis. So if I take the square root of the denominator of that term, I get basically the distance from the center of the curve horizontally out to the curve. Likewise, for the Y term, the square root of the denominator is going to be half the vertical term. And it's the third part of this puzzle is that the distance horizontally from the center, in this case horizontally, from the center out along the main axis to the focus point, that's going to be C. And all of those things are similar here. Half of the longer axis is A, half of the shorter axis is B. The distance along the main axis, major axis here, to the focus point is also C. In both cases, the relationship between the three things is the Pythagorean one. A squared is equal to B squared plus C squared. And we can always take a second and confirm that A must be the largest of the three, which is why we treat it as the hypotenuse. The long axis is obviously longer than the short axis. The long axis is longer than the distance out on the hypotenuse, on the main axis, because the focal point is inside the shape. So you're not going all the way out to the edge. Okay, moving forward, there's a paragraph here that kind of explains that when you first look at a problem, a couple of things should be the instant focus. Which direction is it? Is it oriented horizontally or vertically? Easiest way to tell, whichever one has the largest number, that's going to tell you it goes out further in that direction. And secondly, where's the center? The H and K in the numerator tells you immediately where the center is. And if you know the center in the orientation, you're well on your way to graphing it and knowing everything about it. Okay, so for the rest of these problems, I'm going to have you pause the video for each problem. And when you're ready to discuss the solution, go ahead and unpause it. We'll go over the solution and then pause it again for the next one. So go ahead and do that for the first one. Pause now. Okay, so in the first problem, the center is 0, 0, since we don't see an H and a K, and the larger number is under the X term. Notice they're not in the same order we're used to, but so you got to watch the X versus the Y. So the longer direction is in the X term, so it's a horizontal ellipse with a center at 0, 0. And if we take the square roots, the square root of the number under the x's is 5. So we go out horizontally 5 units in either direction, which puts the vertices at plus or minus 5, 0. And to find where the foci are, we're going to have to use the Pythagorean relationship. So vertices plus or minus 5, 0. And then we know that A squared equals b squared plus c squared. And we know a squared is the 25 because it's the longer one, and b squared is 21. So solving this relationship for c, we get c squared equals 4, which means c equals 2. And so our foci are two units to the left and right from 0, 0, which put them at plus or minus 2, comma 0. Okay, pause it and work the next one. Okay, the first thing you might notice about the next problem is that it's not in the standard form that we've seen for the ellipses. The 8 and the 6 seem like problems, but the first thing I'm going to address is the fact that it's not equal to 1, because every ellipse that we've seen is set equal to 1. And so I'm going to fix this by dividing through by 24 and see if that doesn't take care of all our problems. If we divide through by 24, then the first term I can cancel an 8 out, and that becomes x squared over 3. In the second term, I can cancel out a 6, and I get y squared over 4. And on the opposite side, I get the 1 as I want it. And so now we can see that h and k are 0, because you can think of the x squared as x minus 0 squared, and the y squared as y minus 0 squared. And so, and the larger number is under the y. So this time it's a vertical ellipse, centered at 0, 0. And the vertical distance to the shape is going to be the square root of the 4. So that's 2 units up and down from 0, 0, which results in vertices of plus 0, plus or minus 2. And then for the foci, again, we have to solve for c. So a squared equals b squared plus c squared. Notice when you're solving for c squared, it's essentially always going to be the difference of the two denominators of the ellipse. So I'm just going to be subtracting 4 minus 3. And get c squared equals 1. So c is equal to 1. And so for the foci, I need to go up and down 1 from 0, 0. And that would put me at 0 plus or minus 1. Okay, pause it while you work the next one. So for this one, the center is located at 0, negative 3. The larger number is under the x, so this is horizontally laid out. And the square root of the number under the x would be 8. So we need to go 8 units for the major axis, 8 units left and right. So that would take me to negative 8, comma, negative 3, and positive 8, comma, negative 3. And then the square root of the number under the y's is 6. So we go up and down 6. That'll take me to 0, positive 3, and 0, negative 9. And if we just connect the dots, we've got our ellipse. Okay. Pause it while you work the next one. Okay. This one is centered at negative 2, positive 1. And it has a longer axis in the vertical direction, goes up and down 4. So we'll go down to negative 3, and up 4 would take me to 5. And left and right 2, which will make it just touch the y-axis right here by the 2 units to the right of the center, and there's my ellipse. 2 sideways, 4 up and down. Okay, pause it while you work the next one. Okay, in number 5, they gave us the foci, and one of the things we can get from that is that the center must be the point right smack in the middle. If we average those two, we get 0, 0. So that's our center, which allows us to then start the equation, x minus 0 squared, y minus 0 squared. We also know the major axis has length 10, and because of the layout of the foci, we know that the major axis is the horizontal one. So semi-major is 5, so square that, we get 25 for this denominator, and c is 2 from this, so that gives us c squared is 4, and we've got a squared, so 25 equals b squared plus 4, which leads us to b squared is 21. And we can fill that in, and we're done. Okay, go ahead and pause for the. Okay, similar to the last one, once you lay out the givens, you know that the center is going to be halfway in between those 2 points. So if we average, we get 1, 2 for the center. So we can start our equation, x minus 1 quantity squared plus y minus 2 quantity squared equals 1. We know, since those are the ends of the major axis, that a is 6. So a squared is 36, and that's vertical this time, so we put it under the y. And the minor axis is length 8, meaning the semi-minor axis is 4, and square that, and you put it under the x term, and we're done. Pause it for the next one. In the numerators, we can figure out the center is negative 4, 3. The larger number is under the x's, so it's horizontally laid out with an a value of 5. So the vertices are going to be 5 to the left and right of that. So that will be negative 9, 3 and positive 1, 3. And then to find the foci, we need to find the c values. And we can do that by solving 25 equals 16 plus c squared, leading to c squared equals 9. So c equals 3. And that means go left and right 3 from the center. So that'll be negative 7, 3 and negative 1, 3. Pause it to do the next. In this last problem, we have to complete the square for the x terms and the y terms. So first of all, group the x terms together and group the y terms together. And I usually move any constant over to the other side just to get it out of the way. So we got the x terms and we got the y terms. And I'll add 23 to both sides to get it over here. Now factor out a common factor, or factor out the leading coefficient of the x squared and the y squared terms. So if I take a 9 out of the first group, notice I'm leaving a little extra room because I'm going to put something in there. And I factor a 4 out of the second group, again, leaving a little bit of extra room. Now, to complete the square, the trick is you take the linear coefficient, the coefficient of the x and the y, not the square, cut it in half, square it, and that tells you the constant that needs to be right in that little extra room that I gave you to make it a perfect square. Same thing here, half of 2 is 1, square it, add it in there. Now you can't just add something to one side of an equation and not both. So realize that when I put this 1 in here, because of the 9 in front of that parentheses, I really added 9 to the left side. So we're going to add 9 to the right side. When I put this 1 in this parentheses, I really added 4 to the left side. So I've got to add 4 to the right side. So now the right side becomes 36. And on the left side, if I factor these blocks, this is x minus 1 quantity squared. And this is y plus 1 quantity squared. And now we solve it by just dividing through by 36, which gives us x minus 1 squared over 4 plus y plus 1 squared over 9 is equal to 1. And I'm going to write the answer up because it's very similar to the others. So hang on just a second for the answer. Go ahead and check your final answers in the bottom left. And we're done. Great job today.